Hey, what's up, folks? How's it going? This is Avijit here, and welcome to DevOps Training Hub. So let's start with today's interview question, and let me share my screen. So today's interview question is about uh, what is multi-availability zone deployment versus read replicas in AWS RDS, and when to use each. And second question is how can RDS handles failover and disaster recovery? So we'll explain these terminologies: availability zone deployment, read replicas. So what is availability zone? Availability zone is like in a particular region, Mumbai region, there are multiple data centers for there, right? So those are availability zones. Now in one availability zone, you will have one primary database. And in another availability zone, you will have synchronous standby replica. So it is synchronously copied. So when we are doing write here in the primary DB, that write should automatically happen in the another availability zone also in that replica database. If it fails, then this also will be rolled back. So it's synchronous. So both of them will be in the same uh, status always. Like so, same kind of data configuration, everything should be same. Now, if one data center goes down, something happened. So another data center, you have a replica database that will take over. So DNS will switch to the second one. So that's the multi-availability zone deployment. It's mainly for high availability. So high availability and failover. It's for high availability and failover. So if failover happens, to maintain the high availability of the service, we are doing multi-availability zone deployment. The second question is RDS read replicas and how do you implement? What are RDS read replicas? So read replicas is a read-only copy. So there will be copy database and you will be able to do only read operation. There won't be any write operation. So earlier one, that copy database, it is a read write both. It will read write happen both. In case it will always write and it should be synchronously written. Otherwise, a database will be different. And when failovers, then it will start reading also. But here you have a main database and reading and writing in the main database. And now you see that a lot of traffic are coming. They just want to read the information. Like they are just browsing the data, browsing catalogs, etc., fetching the product information. So it's only read operation. It's only read operation happening. There is no write operation happening. Like a lot of read operation happening. So for that, you have another database. From there, read operation will happen. And once you write in this database, it won't be synced immediately. Maybe after a couple of seconds, that data base will be synced. So it's an asynchronous operation. So there is no write operation. Okay. So it's mainly for scalability. Its purpose is to offload read heavy workload scale horizontally. That is the purpose of read replicas. Offload read heavy workload scale horizontally. Use cases will be analytics, reporting queries, scaling reads for high traffic apps, processing replicas for global read access. So this is the read replica. Now let's have a quick look at Amazon deployment read replicas. Synchronous, asynchronous. Its purpose is high availability failover for availability zone. If one fails, it will switch to traffic, will be switched to another one. And here, if traffic is more of a read-only traffic, or all the read traffic, we can divert to that database. It's for scalability, so that I can handle more traffic, read-only traffic. Here, only primary access rights. And replica will be a read-only. Failover automatic. Here, it's not automatic unless promoted. Cross-region, no. Here, there will be cross-region read replica available. Use cases, it's mainly for reliability and disaster recovery. This is for performance and global distribution. So this is for performance. So a lot of traffic is coming, which is trying to read. So if you have only one database, it will be performance will be affected. So another database is provided from where you can read. Write operation will be happen only in the main primary database. Okay. And now let's go to okay. Now understand the synchronous replication and Asynchronous replication. So synchronous replication means every transaction must be written into both. So every transaction, whatever write operation, it should be written into availability zone A. Also, it should be written into availability zone B. Then only transaction is considered as committed. Suppose you run this query, insert into order values this laptop 70,000. So data is written to primary database US is 1A. Before confirming success, at this ensures same transaction is successfully written to the standby US is 1B. Only then it does send OK back to application. If AZA fails, RDS automatically fails over AZB without data loss because both had same data all times. So this is synchronous because there is a write happening. It's a synchronous because there is a write happening. So it ensures zero data loss, but slightly higher latency because it waits for acknowledgement from both sides. So it will be latency will be slightly higher. Read replica means there will be another. It's a for performance and scalability setup. You create one more replica in same or other availability zone, and they are used for read queries only. No write. There won't be any write into it. The write will be happening only once. So there is no synchronous operation. A write will happen here, and after 2-3 seconds, you can pass on that write to another database, read replica database. So that's why it's asynchronous. Okay. And now, that means if primary fails, if a replica might not have the last few transactions. So that chance is there. Like if primary fails and read replica might not have the last few transactions, there may be possible data loss. So now let's understand what is failover and disaster recovery. Failover means like automatically it will happen, right? You have, let's say Mumbai region, there are multiple data centers or multiple availability zones. You have primary database and that secondary database, which is on standby. Primary database, that data center goes down. So traffic will be diverted to the secondary database automatically, right? DNS will be pointing to that automatically. So update the DNS name, so your app automatically connects to the new one. This process usually finishes within 30 to 120 seconds, within 1-2 minutes. So you don't have to do anything; it happens automatically. This failover is automatic, right? So primary database in US 1A crashes, RDS quickly switches to standby in US 1B, and your app keeps running after a short pause. There will be a short pause, after that it will keep running. But what happens when there is a disaster? Whole region is like for some reason gone down. Okay, whole region is affected. It's a big failure. Like entire AWS region is going down. To prepare for this, you need to take a backup, cross region backup. So if one region is going down, so another region will have to keep it ready. So you can promote the replica to become a new main database in another region, and then from backup you have to recover whatever data was not synced, etc. So snapshot copy will be recovered. So disaster recovery is for big failure, small failure, availability zone level failure. You go for failover where automatic transition will happen. But here, disaster recovery, you have to, if your main region fails, you can restore the database from that snapshot in a new region. So it has to be restored. It will take some time. Aurora global database for Aurora user. Aurora can replicate data across regions in under a second. So that is a feature of Aurora global database. It can replicate across region. Right? Two different regions it can replicate. If one region fails, another region can take over almost instantly. So it can become almost instantly, even for disaster recovery also. So let's say your main RDS database in US is one, Virginia. If availability zone fails, multi-agent failover happens and automatically within 1-2 minutes. If the whole region fails, you can promote your cross-region replica in US West 2 to make it a new main database. So in short, a single availability zone fails, it's a multi-agent failover, auto switch to standby. Whole region fails, it's a complete disaster. So it's a disaster recovery. You promote another replica as a primary one from another region. Okay, so now let's go to today's quiz section. You can pause the video and try to answer. What is the main purpose of multi-agent deployment in Amazon RDS. What is the main purpose? Main purpose of multi-agent deployment is high availability and automatic failover. High availability and automatic failover. So if one region, the availability zone fails, traffic will be diverted to another availability zone. What is the main purpose of read replica? It is for scaling read workload, and offloading analytics query. So read replica are asynchronous copies of the primary database used to offload read-heavy workload. So it will offload read-heavy workload. Read replica. That's why it's called read replica. The next question is, what statement correctly differentiate multi-agent and read replica? So multi-agent is synchronous, read replica is asynchronous. The answer is C. Multi-agent is synchronous, read replica is asynchronous. Which of the following statement about multi-agent deployment is true? Multi-agent deployment provides automatic failover with no data loss. Because here there is a synchronous one, right? So there is no data loss. This is synchronous replication for zero data loss. So AWS handles automatic failover transparently via DNS switch. When you create an RDS read replica, what kind of replication does AWS yield? RDS replica, it's a asynchronous, right? Asynchronous replication. Read replica, asynchronous replication, because there is no write here, right? So there may be slightly lag between primary and replica. What happens when primary instance in multi-agent deployment fails? Primary instance fails means AWS automatically promotes standby to a primary and updates DNS. This will be automatically happen. AWS automatically performs automatic failover to standby and updates the same DNS endpoint, minimizing downtime. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel, and also follow my LinkedIn page, DevOps Calendar. I post quiz contest daily. You can participate in that. Also join my WhatsApp communities. I post regular job updates, career tips, interview tips, etc. Thank you for watching this video. See you again in the next video.